Welcome to today's class. Look at this question before us here. We have the square root of x plus the square root of y equal to 10. Let's take this as our equation 1. And the square root of xy equal to 10 again. Alright, this is serious. From here, we discover that we're going to have what we call conjugate answers, conjugate roots. X is going to be the conjugate of our y, and y is going to be the conjugate of our x from what we have here so far. So from here, we take our solution. All right. So from here, we want to take the square of both sides of equation 1. So we want to square both sides of equation 1. So from here, we're going to have this to be our equation 1. We have x there plus square root of our y. So all to the power of 2. This is equal to 10 to the power of 2 also. So if we square this, what happens? Let's open it gradually. So we have here square root of x there to the square root of y bracket the square root of x plus the square root of y bracket. This is equal to, we have our 100. This other side we don't have problem with. Let's open up these quantities here. So this we times it to give us here the square root of x all to the power of 2 there plus this time this will give us square root of x y there plus we use this to times this will give us the square root of our x y there plus we use this to times this to give us the square root of y all raised to the power of 2 equal to 100. Okay, then from here, this radical will go with this radical will go with this. So we can add these two together. It is going to give us our x plus 2 into the square root of x, y, then plus our y equal to 100. So we have the equation from here now, which is x plus y, then plus 2 root x, y equal to 100. But what can you see from here? We discover that we have xy as our equation 2 here. So what is the value is 10. So we can put in 10 here. Give us here our x plus our y plus 2 into 10 is bracket equal to 100. So open up to give us x plus y plus 20 equal to 100. Move this to this side to give us our x plus our y equal to 100 minus 20. Then we have x plus y now be equal to 80. Let's give this equation 3. If we hold this as equation 3, then we now go over to square equation 2. Look at our equation 2. So let's also square equation 2, right? So now say from equation 2, our equation 2, go to square both sides. So we have the square root of our x, y, all squared is equal to the square the right hand side also. So this goes with the radical. So we now have x, y now be equal to our 100. Wow. So for what we have here now, we discover something from here. Here, we make either x or y the subject of the formula. But let's give this equation 4. So if we make y the subject of the formula, we're going to have here y equal to 100 all over our x. So let's give this equation 5. Okay, so from here now, let's put this expression we have here now into equation 3. So let's put equation 5 into equation 3. You remember we got our equation 3 from the square of equation 1 and equation 5 from the square of our equation 2. So let's put equation 5 into equation 3. So say here, put equation 5 into equation 3. So our equation 3 is x plus y equal to 80. So wherever we see y, let's put in this quantity here. So this is going to give us our x plus 100 all over our x here, right? Then equal to 80. So from here, let's eliminate this x at the denominator here. We multiply through by that x. So this is going to give us x times x plus our 100 all over x times x equal to 80 times our x. Also, from here, this is going to give us our x to the power of 2 plus 100 is equal to 80x. Move the 80x on the right hand side to the left hand side. This is going to give us our x to the power of 2 plus our 100 minus 80x equal to 0. So rearranging, we have x to the power of 2 minus 80x plus 100 equal to 0. So what kind of equation is this? This is a quadratic equation. So how do we solve this now? Can we solve this using the factorization method? It will pose some challenges. So let's go ahead to solve it using the formula method. So from here, using the formula method, using formula method, to bring out our formula. So here we have x is going to give us the x now be equal to minus b plus minus the square root of our b squared minus 4ac everything all over 2a, right? Good. So we bring out our a. What is a here? A is the coefficient of the x squared, which is 1. The b is the coefficient of ordinary x, which is minus 80, and c is the constant term, which is positive 100. So we can substitute these values into the formula. So this is going to give us our x now be equal to minus our bracket minus 80 close bracket plus minus the square root of our minus 80 close bracket all squared minus 4 into 1 into our c is 100 close bracket everything all over 2 into 1, right? Good. So minus times minus will give us plus. So from here, we're going to have our x now be equal to positive 80 plus minus square root is going to give us 400, right? Minus our 400 all over. The denominator will give us 2. Yeah. So this will give us equal to 80 plus minus square root. If we subtract this from this, we are left with 600 all over 2. Wow. Now, our 600 can be expressed as 400 times 15 because 400 is a perfect square. Okay? So if we go ahead to do that, it's going to give us 880 plus the square root of 400 times 15. This is all over 2. Easy. So square root of 100 will give us 20, right? So if we write this, it's going to give us 80 plus minus 20 to the square root of 15 all over 2. We can factor something from here. We can factor 20 from this expression we have here now, right? Yes. So let's go ahead and factor 20 out. So this is going to give us 20 into, if we use 20 to divide this will give us 4. Then plus minus, use 20 to divide this will give us 1. So we are left with 15, square root of 15. Bracket all over 2. Easy. Then something can strike out here. 2 here 1, 2 here we have 10. So we now have our x here to be equal to 10 into 4 plus minus square root of 15. We have x1 and x2 from this challenge so far. So let's go ahead and bring out the value of our x1 and x2. So this is going to give us here, we have our x1 now be equal to 10. First one we take the positive, so we have here 4 into square root of 15, close bracket, and our x2 we take the negative, which is 10 into our 4 minus square root of 15. Okay, so let's keep these two roots. Yeah. So we want to solve for our y1 and y2. Since we have x1 and x2, definitely we're going to have y1 and y2. And how do we get our y1 and y2? We recall from one of the equations we have established, which is equation 5. Look at this here. From our equation 5, y has been made the subject of the formula. So from here, we now say from equation 5, from equation 5, we know that our y is equal to 100 all over our x, right? Good. So wherever we see x, let's put in our test root. So for our y1, so for our y1, this is going to give us here our 100 all over first root here, which is x1, is going to give us here 10 bracket 4 plus the square root of 15 close bracket. Easy. Okay. Now we can cancel out 10 from here. And what we can see from here now. So 10 here, 1, 10 here give us 10. So we now have this to be our 10 all over our 4 plus square root of 15. Now look at what we have here now. This is solved. So we can rationalize the denominator. So if we rationalize the denominator, we multiply by the conjugate. This is going to be 10 into 4 minus the square root of 15, which is the conjugate. We equally do that to the denominator, which is our 4 plus square root of 15 into its full conjugate, which is 4 minus the square root of 15. Right. Good. So if we do this, this is going to give us our 10, then bracket 4 minus the square root of 15 close bracket all over. Because we are multiplying this one by its own conjugate, so what happens? It is simple. So we're going to end up having 10, 44 to the power of 2, then minus square root of 15 all to the power of 2. Wow. So this is going to give us something unique. So we have 10 bracket 4 minus square root of 15 close bracket all over 16 minus this power goes with this radical here. So we have 15. So end up having our y1. So we can say therefore our y1 is equal to what here we have 10 bracket 4 minus the square root of 15. Oh my goodness, this is serious and this is crazy. Okay, then if we go with this same procedure, we're going to have our y2 to be our 10 bracket 4 plus square root of 15. Okay, so this is what I said the other time, that we're going to have answer of x conjugate to the answer of y. Okay, so therefore our x comma y, we have two pairs of answer from this now. So we now have therefore our x comma our y, we have this to be equal to the first pair, we have our x to be this, right? 10, then into 4 plus square root of 15, right? Then our y, what is our y? Look at our y. We have 10 into square root of 4 minus the square root of 15, those brackets. Okay, then comma, the other one we have it to be our x2. Look at our x2. So what is our x2? Our x2 is our 10 bracket our 4 minus the square root of 15, right? A comma, we have our y2 is 10 bracket open 4 plus the square root of our 15, close bracket. So let's put in our square bracket to cover everything here and this here. All right. So this brings us to the end of this math class. So if you learned something from this video tutorial, give the video a thumbs up. And if you are not clear with any of the procedure we apply in solving this math challenge, drop it in the comment section. Okay, we are there to reply to all your comments. Remember, this is Math Prowess, and all of us here, we love you dearly. Thanks for watching our content. Bye.